Assalamualaikum. I'm Rosimawati and I would like to present about the introductions in this experiment drilling mud densities in oil industry. Mud weight is the densities of the drilling fluid and normally measured in pound per gallon ppg or pound cubic feet pcf. The densities of the drilling fluid is normally determined at standard condition, which is 0 psi and 70 Fahrenheit. The purpose of the drilling mud is removal of cutting from the bottoms of the hole, suspend cuttings and weight material, transport cutting and cast to the surface. The most important features of any drilling fluid systems is that the interactions between the mud and the drill formations must have a minimal effects on the mechanical properties of the formation. The larger number of functions performed by the drilling fluid requires some minimum properties of the fluids be maintained. Strong and competent formation can be drilled with a density less than 1.0, but overpressure shields and high pressure formation may require a fluid with specific gravities approaching 2.4. Drilling fluid can be classified in three types, which are water-based mud, oil-based mud, and air. Air drilling such as mist, foam, and stiff foams are used in only a very specific or limited application. Water-based drilling fluid are commonly used of the mud system. It is less expensive and less difficult to maintain than oil muds. In addition, oil mud was developed to prevent water from entering the pore space and causing formation damage. Several advantages of oil-based mud are shale inhibition, reductions of torque and drag problems, resistance to chemical contaminant, and etc. In this experiment, the densities of specific mud is measured to know which mud is good use for a specific wellbore.
So the objective for this experiment is to identify the density of different samples of drilling mud, which in this lab we are using oil-based mud and water-based mud. Now we go to the theory for this experiment. Drilling mud density experiment as a reflection of density of mud during drilling process, which are performed to control an adequate hydrostatic pressure and influx from the formation can be avoided. Density measure fluid of weight per unit of volume, which for industry measure it in pound per gallon, or we call it in ppg. Drilling fluids is designed to reduce the damage effect for the formation and equipment while make sure that the rotary drilling can be drilled deeper without increasing the temperature of the drill bit. Besides that, it is to avoid an excessive loss return to the formation and to fulfill the dual of opposing formation pressure. In field, mud balance and hydrometer are frequently used to determine the density of mud, and usually the density is reported to be near 0.1 ppg. The first section for this experiment is using a mud balance. This mud balance is designed so that the mud cup at one end arm is balanced according to the opposite end. One end installed with a sliding weight rider which can be moved along a graduated scale. A level bubble is mounted on the beam to avoid any error during measurement. The bubble can be significantly reducing the pressure of the fluid, hence causing an error. The density of fluid contained in train, air, or gas can be determined accurately measured by using a pressure-fluid density balance. On the front side are the measuring scale with a range of 6 to 24 pound per gallon and specific gravity of 0.72 up to 2.88 gram per centimeter cube. Behind front measurement contains scale with a range of 45 to 180 pound per cubic feet, and for the density is 310 to 1250 pound per inch square per feet. The second section of this experiment is using hydrometer. Hydrometer is an equipment which to calculate the specific gravity of liquid where it will represent the ratio of the density of fluid. Theoretically, the result of determining the density of mud using mud balance is more accurate compared with the hydrometer. For this experiment, hydrometer used to determine the density where a floating bubble is placed inside a cylindrical glass tube filled with the mud equipment with a rubber ball at the top end, which used for sucking liquid into the tube. This experiment used two samples, which are oil-based mud and water-based mud, where technically oil-based mud is more denser compared with the water-based mud, which will be experiment at a high temperature and pressure.
Thank you, Hanis and Hanani. Now I will proceed to the apparatus and materials, also the procedure, and last but not least, the result for this experiment. First of all, the apparatus that we will be using for this experiment, we have three apparatus. First is the measuring cylinder to measure the materials, and the mud balance, which is the equipment that we use for the first experiment, and the hydrometer, which equipment is used during the second experiment. As for the materials, we will have two types of material. First, the water-based mud, and second, the oil-based mud. Okay, proceed to the procedure. For the experiment 1, determination of drilling mud density using mud balance, as I stated before. And before the experiment, we will need to ensure the accuracy of its reading by filling the cup of mud balance and tested it with water first. This is done in order to reduce the error produced during the experiment. As for the procedure for the experiment, this experiment is rather easy and simple. We will have three steps. First, fill the cup of mud balance with oil-based mud. Then, second, place the lid on the cup and set it firmly. Make sure that some of the mud that spill out must through the hole on the lid. Third, record the reading density of the mud. This experiment was repeated for 3 times in order to obtain the average value. The average value will reduce, which properly calculated to reduce the error produced during the experiment. This experiment will be reconducted with the same step and the same procedure, but using water-based mud. Okay, proceed to experiment 2. The determination of drilling mud density using hydrometer. Before the experiment, we will need to measure the 400 milliliter of oil-based mud using the measuring cylinder. Second, we will need to choose the suitable hydrometer that have the function of measuring the specific gravity. And the third one is ensuring the hydrometer is totally clean and dry. Okay, as for the procedure, we will only have 2 steps, which is the first one is place the hydrometer in the measuring cylinder that we measured before, and second, spin it a little bit and record the reading of the hydrometer. Simple, right? The experiment was repeated for 2 times, which with the same purpose as the previous experiment, which is to find the average value. And same as before, this experiment will be reconducted using the water-based mud. Okay, done with the procedure, let's proceed to the result. Experiment 1. We repeat the experiment for 3 times, right? So we will need to calculate the average value. So to obtain the average value for the first experiment and also the second experiment, we will be using the simple formula, which is the average reading. So the formula is by adding the value for test 1, test 2 and test 3. This is according to how many times you repeat the experiment divided by the number of tests that you conduct for this experiment. So the sample calculation is like this. The average value, like, okay, back experiment 1. Okay, we have this test which 1.9, 1.8 and 1.9. The average is 1.87. Okay, so the calculation will be like this. 1.9 plus 1.8 plus 1.9 divided by number of tests is 3 tests. So the average value we obtain is 1.87 specific gravity. This will be applied throughout the both experiment. Okay, next we will need to convert the unit from SG to the density. The formula we will be using is Sg equal to density of substance over density of reference. As for the density of reference, we will be using 1000 kg per meter cube. Okay, to obtain the density substance, we will need to move the density of reference to the other side. Then the operation will be converted to multiply Sg specific gravity multiplied by the density of reference. We will get the density of substance. As for the sample, the density water-based mud, which is 1.87, we calculated it before, times 1000, we will get 1870 kg per meter cube. Okay, after you calculate for both experiments, this will be the final result. The unit will be kg per meter cube, and the method mud balance for the first experiment and second experiment, the hydrometer, water-based mud and oil-based mud. And as for
thank you, Zakri, for giving me the opportunity to discuss further for the experiment for mud density. Okay, for this lab, I will be discussing this experiment. I'm Harith Bin Aimiros, and I will be explaining about the lab experiment mud density. Okay. The experiment conducted is to determine the mud density of the sample using both of the equipment, which is the hydrometer and the mud balance. The samples used for both apparatus are oil-based mud and water-based mud. From the experiment result, both apparatus give different result, which is the result is in specific gravity unit. After that, the specific gravity data then converted into unit of density, which is kg over meter cube. And then the data acquired using mud balance from the result is more accurate than hydrometer. Why is that? The experiment for each apparatus is repeated multiple times in order to gain more consistent reading throughout the experiment. And then the data gathered from the multiple time of experiment is added, resulting in average density for each apparatus. Why is hydrometer is more unreliable than mud balance equipment? Hydrometer is inaccurate and unreliable due to the gelation of the sample during data acquisition process. What is gelation of the sample? When the sample going through the equipment, the sample tend to stuck, then require more pressure or less pressure that can resulting faulty result for the experiment. The volume of space of the hydrometer may be occupied with gas and air bubble from the sample can lead to inaccuracy in the data. That's why mud balance is more accurate and more reliable than the hydrometer. The reason why its hydrometer is also not reliable because hydrometer is not durable due to the fragility of the apparatus. Hence, the experiment cannot be repeated multiple times due to the fragility of the apparatus. Besides that, hydrometer also requires specific scaling for each fluid density that needed to be tested for one hydrometer. That means we need multiple hydrometer for each of the sample and take time to calibrate the specific scaling for each fluid density that we must record it for this experiment. So as a conclusion for the experiment, using mud balance is more accurate than hydrometer, and the result from mud balance is more reliable. That's all from us. Thank you.